All right, hey, this is Mr. Barr, and today is One None Infinite Part 2. But first, we've got fires going on in the area. So school is actually, even the distance learning part of school is closed right now. But I'm at work. But I bet some of you have been seeing those fire dropping planes doing their things. And that is some awesome, incredible stuff. And I want to use that as a little bit of an encouragement for you to recognize that what's going on with that fire, the fire science guys and the pilots and the people running that, they all had to get through some crazy math classes to get to where they're at. Because the science of fire involves a bunch of equations and a bunch of physics, and these guys took a bunch of math classes in high school and college to do the jobs they're doing. So that's one of the reasons we get through the math, is because our world depends on it. All right, so One None Infinite Part 2. I can solve linear equations in one variable. Math has its own language and rules. By solving equations, I learn the language of math and how it works. So today we're going to ramp up the concept from the previous lessons. We're going to determine one none infinite for more complex equations. But more importantly, we're going to use our knowledge to actually create equations that have one, none, and infinite solutions. So we've already started with this a little while back, and we did this. We figured out that one solution, the x's don't cancel out. For no solution, the x's cancel out, but nothing else cancels out. And for infinite solutions, everything cancels out. So that's our jumping off point for today. So we're going to make one more thinking map. So here are our notes. Equations, part 2, one none infinite, part 2, and make sure you get a name on there. Need those names. Now we're going to go right into a thinking map with it. So we're going to go with types of equations, or types of solutions. And the types we're going to have are one, none, and infinite. And I'm going to change the language a little bit here. So for the one, if we have two, let me get a better marker. 2x plus 5 equals 6x plus 2. And if I just look at the coefficients in front of the x, that tells me, this is going to tell me everything I need to know right there. So right here, one solution, different x coefficients. And that's the number in front of the x's. So if we have different x coefficients, that means there's going to be one solution. For a no solution, same x coefficients, those are the numbers in front of the x's, different constants. And the constants are the air bubbles, just the numbers. When it comes to the infinite, Everything's the same, right? Same. Oh, let me give you an example. Same x coefficients, same constants. And really, using this thinking map and the previous thinking map, it's everything we need to do these problems. So let's do some problems here. Before I do this one, I have to simplify everything down first. We're going to do this one in our notes, and then I'll just start doing them on the computer. And my lights just went out. Let me get my lights back on. So in our notes, let's write this one down. I have 12x plus 5 minus 14x equals 9x minus 8x minus, that wasn't an 8x, that's just an 8, isn't it? I'll get rid of that x. It's hard to erase Sharpie. Before I do anything, I need to simplify this down. Need to combine like terms. So I have 12x minus 14x, that's negative 2x, plus 5, equals 9x minus 11x is negative 2x, minus 8. And now I can make the decision. And this is telling me there is no solution. 5 equals negative 8, no solution. So what do I need to do? I need to simplify, combine terms, and make a conclusion. So let's get that into our notes. Here are our steps. We'll do this one as a thinking map, a flow map. Distribute. Well, that marker does not want to be in my life anymore. The marker will be gone. Distribute. Simplify. Decide. Distribute, simplify, decide what it is. Okay, so let's do some on the computer. Let me get my drawing tablet ready to go, my pen. I'm still here. I know you guys are thinking, Mr. Barr, why don't you have everything ready to go when you first start your videos? Because I don't. Okay. Distribute, simplify, decide. Distribute, simplify, decide. There we go. Those are our instructions. All right, here we go. Distribute. Okay. Here we go. No distribution to do here, but I can simplify this down. It's going to take me to 12x plus 0 equals 14x. Okay. Well, the coefficients on the x's are different, which means there's going to be one solution on this. All right, no distribution, but I can simplify this down. That's going to become 10x. 16 minus 21 is negative 5 equals 12x minus 5. Well, right here, 12 and 10 are different, which means there's one solution. Ooh, good. Get a little distribution here, some distribution. 6x plus 21 equals 6x plus 24 minus 3. Distribution done. Combining terms, 6x plus 21 equals 6x plus 21. Make a conclusion. We combine those terms. This tells me they're infinite solutions. All right, so 13x minus 7, nothing to do there. A little distribution, 12x minus 12 plus x plus 5. Combining terms, 13x minus 7, nothing to do there, equals 12x plus x is 13x. Negative 12 plus 5 is a negative 7. Infinite solutions. Distribute, combine terms, make a conclusion. All right. So in this one, we want to actually make it one solution. So I'm going to follow the idea here. Distribute, that's going to give me 21x plus 27 equals something x plus something. Make it one solution. Okay, let's go back on my notes. One solution. One solution. Different x coefficients. So I need to put an x here, and it just has to be different from this. I have to put something here, and it's just got to be different from 21. So pick a number that's different from 21. How about 20? There we go. And over here, this does not matter. Whatever you want to put here, 0, 5, 8, negative 10. 8, I like 8. It's done. It all happened right here when I decided that I had different coefficients. Make it no solution. All right. Start with some distribution. What does no solution look like? Same x, different constants. I shouldn't have put a B there. That should be a space. Okay. Same x. There we go. Same x, different constants. Same x, different constants. No solution. Make it infinite solutions. Okay, I've got this. 21x plus 27 equals ax plus b. Infinite solutions. Everything's the same. Make it no solution. I've got this. No solution. A little distribution. Negative 3x plus 19 equals x plus. Okay. No solution. Same x's. Different constants. Make it one solution. One solution, different x's. Different x's, so this is a negative 3, so maybe just a 5. Different x's, I do not even care about this one. Notice it doesn't even mention the constant terms, so I can go with 19 again if I want to. Make it infinite solutions. Negative 3x plus 19 equals blank x plus blank. Infinite solutions means that they're identical, so negative 3 and a 19. Infinite solutions. All right. Thank you for watching, and I will see you later.